I recently had a reader of my blog send me a note asking me if there's any way he could use the GE's FME plugin to send a node information to FME. Typically you can't do that, at least not with the GE FME plugin, because that plugin pretty much just sends data that's available on user-defined tables, like a cable or a conductor. It does not send information that's included in system tables, like the node table. So what you would see if you're trying to import a cable as it is right now, we'll pick the cable center line. You expand the feature attributes there, you'll see ID known as voltage, status, and length, but you won't see any way of getting in at the nodes. What you can do though is you can make use of something called FME pseudo fields. So on the record exemplar class for the table that you're interested in exporting, you can define a shared constant called FME pseudo fields, and you can put one or more FME pseudo field factory classes with a call to new derived field. The first argument is a symbol which represents the field name as well as the corresponding Magik code, which will return the value for that field, for that pseudo field. And the second attribute is the field type. You can just keep this as extdb_string. When you set that up, the requirement here was to find the cable's nodes and then ask each of those nodes for its coordinate and somehow send that information to FME. So I wasn't sure whether it would be more helpful to have the node coordinates in the database units or to have the node coordinates in a long lat coordinate system. So I did both. And it turns out that regardless of whether you want to use database units or long lat, the underlying code is the same. So then I made a helper method here. It basically says return the node coordinates as a string. So I get a hold of the center line. If there is no center line, then the result is an empty string. Otherwise, we loop over every node and we ask that node for its coordinate information, and we make a string, an XY coordinate string that FME can understand by doing a comma delimited string concatenation. And then for each one of those pairs, we can concatenate the pairs with a pipe. So if we have 5 coordinates, 5 nodes in that chain, we're going to get 5 XY pairs, all delimited with a pipe. And it turns out, like I said, all the code was the same, but underlying, the only difference is if you're going to use the database units, then you have to define current coordinate system to be unset. And if you want to do it in long lat coordinate system, then you define the current coordinate system this way. I've defined it, I'm setting it based on a shared constant that I've defined up here. I mean, I could actually put all this code, new projection long lat in here, but that means I'm creating a new object every time for every record that gets sent to FME. So instead I put it in a shared constant. So I only have to make the object once and I reference it after that. So if I compile it now, go back to FME, and I can right click on this guy here and I can say update, and it's going to go get the latest attributes now, or data model that it's aware of, and you can see these two new pseudo fields in here. So if I right click, and just for demonstration purposes I'll just add a visualizer and I'll run it now. That will pop up the FME viewer. Of course, I forgot one important thing. I forgot to set the merge feature type on a wildcard, so we have all the different map geometries. We'll try it again. And now you can see if I click on any one of these, it does the node coordinates here based in database units as well as long lat. So that should be enough information then for you to continue writing your workspace, to maybe parse it or somehow export it to another format that your external system can then make use of.